This video we're going to look at some examples of integration. Our first example is simply to show that if we can know the antiderivative of a function, we can prove that this is the integral. So if we want to integrate log x, then what we need to do is find a function capital F of x such that that's equal the derivative of capital F of x is equal to the function of interest f of x, which in this case is going to be log of x. So we want to integrate log x with respect to x. So let's try the following function. Try the function capital F of x equals x log x minus x plus a constant, an arbitrary constant c, and if we can differentiate capital F of x and recover the original function, then we've proved that this is in fact the integral. So if we differentiate capital F of x, then for the first part we use the product rule, so we get x multiplied by the derivative of log x, which is 1 over x, plus log of x multiplied by the derivative of x, which is 1, minus the derivative of x, which is just 1, and of course the constant drops out. So we're left with log of x. So we've proved that this is in fact the integral. Now we can use that to in our next problem. Our next problem is to find the antiderivative of various functions. We're going to use example C here, where we integrate log of x minus 1 over x squared. And we've in fact done half the work already here. So if we integrate this function, we can separate it into two integrals, the integral of log x with respect to x minus the integral of 1 over x squared with respect to x, and we've done the first part already. So we can write the integral of log x as x log x minus x. Don't worry about the constant term here, because that will be allowed for when we integrate the second part. So we integrate 1 over x squared dx for the second part. So we have x log x minus the integral for x to the minus 2 dx, and we use the standard power function rule to integrate that. So we get x log x minus x minus the integral here, which is simply going to be minus 1 over x, so the two minuses cancel, leaving with plus 1 over x plus the constant. Now we're going to look at an example of definite integration. The difference here is that rather than a function of x, we get a number when we perform definite integration. So we're going to look at example C here, where we integrate the exponential function between the limits 0 and minus infinity. Now, this is an example of an improper integral because we need to evaluate it at minus infinity, and we'll show that as follows. First of all, integrating e to the power of x simply gives us e to the x. Now we need to evaluate that at its limits, so we have e to the power 0 minus, well, here we have to take a limit. We take the limit as x tends to minus infinity of e to the power x, and that's it simply equal to 0, so we're left with the value 1.